So we have discussed one example previously to understand the distance and displacement. I'll go with another example. Okay, so this is east, this is west, this is north, and this is south. Okay, so this is one of the initial point. From this point, your sister or your brother traveled towards west. Where do they go? They are going to buy chocolates in a shop. So they are going to shop, right? So they have traveled up to here 12 meters. The shop is nearby your street, okay, end of your street, and they have traveled 5 meters this way towards the south and reached the shop. Okay, now you have to calculate the distance. So what is distance? So distance definition is the length of the path covered by an object. So this is the distance traveled by the object. First object traveled AB, A to the B, and B to the C. First traveled this length and this length. So what is the total length traveled? Distance is equal to A to the B plus B to the C. This is the distance traveled. Tell me, what is its value? A to the B, what is the value? 12 meters. B to the C, what is the value? 5 meters. Now 12 meters plus 5 meters, 17 meters. That's all. This is the distance traveled. Now we are going to calculate displacement. What is displacement? The shortest distance between initial and final points is called displacement, or the distance of the object, the distance in one direction is also called displacement. Now we are going to calculate the displacement in this problem. Okay, how to calculate? This is the initial point, this is the final point. Shortest distance. How do we get the shortest distance? By drawing the straight line. So this is the displacement. Now you have to calculate the displacement. Calculate the displacement related to the right angle triangles. We have Pythagoras theorem. This is 90 degrees, right? It's a 90 degrees triangle, right angle triangle. Opposite to the 90 degrees, which is the side we have, that is called hypotenuse. Okay. Now this is usually longest side in the triangle. So what is the formula? Simple formula. The square of the longest side is equal to the squares of the sum of the squares of the remaining two sides. That means A to the B, that is one side, square of this side and square of this side. If you add the square of this side and square of this side, we will get this one. If we add these both squares of the sides, we will get this side. So AC square is equal to AB square plus BC square. I hope you understand how to apply the Pythagoras theorem. Okay, AC square is equal to AB square. What is the AB value? Length of the AB 12 square plus BC. What is the length of the BC? 5 square, right? Then AC square is equal to 12 square value 144, 12 into 12, 5 square value 25. 5 5 is at 25. Then AC square is equal to 144 plus 25, 169 meters. 169 also can be written as 13 square. 13 square, 13 into 13, 169. Square cancel. Then we get AC is equal to 13 meters. But what is the major difference between the distance and displacement? Distance has no direction, as direction is changed here. Is this object traveled only in one direction? No, direction changed. But displacement, it has direction, only one direction. Okay, distance in one direction is called displacement. So one direction, so that is why we have to mention here direction towards. Tell me, what is this direction refers? This direction refers this way, right? So this is southwest. What is the direction? Southwest, towards the southwest. Okay, so I hope you understand how to calculate the distance and the displacement, and what is the major difference between the distance and displacement. Okay, see some other important differences between the distance and displacement also we are going to learn. Meanwhile, please note down this. Now we are going to understand the differences between the distance and the displacement. Okay, see, this is one of the example I have written here to understand the difference between the distance and the displacement. A boy traveled 10 meters due east. So while solving the problems related to the distance, displacement, speed, compulsory you have to denote this: east, west, north, south. Okay, in which direction he traveled? Towards east. So this way. Let's say this is the initial point. He traveled from here and he traveled towards east 10 meters and reached other point B. Up to here it is clear. Then, and returned to the same point. So he returned to the initial point from where he started his journey, A. Again he returned to the same point. So in this direction he traveled 10 meters, and also in opposite direction also he traveled 10 meters. If the distance between A to the B is 10 meters, obviously, then what is the distance between B and A? 10 meters. He traveled 10 meters A to the B and 10 meters B to the A. Finally reached the same point. Now what we have to calculate? Distance and displacement. First we calculate the distance. What is distance? The length of the path. Okay, what is the length of the path? First he traveled from A to the B. So this is one length of the path. Again from B to the E, B to the A. So that is other length. Okay. So the total length of the path A to the B and B to the A. So A to the B plus B to the A, that is equal to A to the B. What is the distance traveled? 10 meters. And B to the A, what is the distance traveled? 10 meters. 10 plus 10 together 20 meters. This is the distance traveled by the object. Now we are going to calculate displacement. So before going to calculate, once recall the definition of the displacement. What is the displacement? The shortest distance. The shortest distance between initial and final points is called a displacement. What is the initial point? A. What is the final point? You think B? No. He returned to the same point where he started his journey, A. He traveled towards east up to the B 10 meters. Again he returned to the A. Again he reached the final point also A. Initial point is A. Where he started, there he reached again. So initial point is A, final point is also A. Whenever initial point and final point is same, what is the displacement to travel? No displacement. 0. Okay. So what is your answer? 0. Displacement is 0 because initial and final points are same. Whenever initial point and final points are same, displacement is 0. Tell me some of the real life examples where displacement is 0. If you take a minute's hand of the wall clock, it starts at 12. It starts at 12. Okay. Again, after completion of the distance, it is again reaching the 12 after 1 minute. Tell me what is the displacement? 0, because it starts at 12 and reached again 12. Then what is the displacement? 0. For example, you are going to school every day, right? You have traveled at one point, your house, and you go to school. By evening, after 5 o'clock, again you return to your school. From school, you return to your house. Okay, you reach your house. Then tell me, what is the distance traveled? Distance traveled is something. If you ask your bus driver, he will say, because in bus driver, that odometer which measures the distance. If you ask your father, if you go on your own transport, your father will say what is the distance traveled, because distance traveled by the any object can be read with the help of the odometer. In odometer, the number of meters changes every day, right? Yes, sir. That we can find easily. But what is the displacement? Where you have started from your home? Evening time again, where do you go? Again, you reach your house. Initial point is your house. Final point is also your house. Then tell me, what is the distance traveled by you? Something. What is the displacement traveled by you? 0. So I want to tell you a very important difference between the distance and displacement. Displacement is always something, okay? But displacement sometimes we get 0. So from this, the major difference is displacement can be 0, but distance cannot be 0. Distance means compulsory length of the path. Even though you reached some distance and after again you return to the same point, this distance will be calculated. But displacement cannot be calculated because your initial point and final point is 0. Then what is your displacement? 0. So displacement can be 0, but displacement cannot be 0. It is never. Okay. Distance never be 0. It is always something, right? This is one of the major difference between the distance and displacement. Okay. From the same problem, okay, I extend this problem. Let's see. A boy traveled 10 meters due east and returned in the same path and traveled 20 meters towards due west. Okay. Then find distance and displacement in this case. Okay. Now you see, where is the object started? This is the initial point. First, in which direction he traveled? East direction. This is east. How many meters he traveled? 10 meters. Later he returned in the same path, okay, but he traveled 20 meters this time. So 10 meters up to the A, extra 10 meters he traveled up to C, he traveled up to here, okay. Then we have to calculate, find distance and displacement. Now in this case, what is the distance traveled first? A to the B, that is okay, B to the A and A to the C. A to the B 10 meters, B to the A 10 meters, A to the C also 10 meters, because total 20 meters he traveled, right, towards west 20 meters he traveled. So this is 10 meters, 10 meters, 10 meters. And directly this can be written as BC because he traveled from B to the C. He traveled from B to the C. Directly we are taking this 20, total 30 meters. I hope you understand the difference between the previous problem and this problem. Previously he returned and again reached the same point. So 10 and 10, 20 only. But here he traveled more extra distance. That is calculated here. Now displacement. Previously he reached the same point. Initial point and final point is same. That is why displacement is 0. This time he traveled extra distance. In this problem he traveled some extra distance. Okay. Now we have to calculate the displacement. What is displacement? The shortest distance between the initial and final. Now what is the initial point where he started the journey? A. Where he stopped finally? He stopped finally at C. Yes. What is the initial point? A. What is the final point? C. Actually initially he started his journey towards east, okay. At the end the direction is reversed. The end what happened? Direction is reversed, okay. Then calculate this distance. This is the initial point, this is the final point. B to the C 20 meters, B to the A 10 meters. Then what is the distance between A to the C? 10 meters. So displacement is equal to 10 meters. Displacement is equal to 10 meters. But what is the initial direction? East. Final direction? West. So that is why I will take minus 10 meters. What does this minus refer? This negative sign refers change in the direction. Negative sign refers change in the direction. Original direction is east, but finally direction is reversed. That is why we have to take minus 10. Or you can write this way also. 10 meters towards west also can be written. What is the first direction? East, but finally direction is reversed, okay. So from this example what we can understand? Displacement is positive, sorry, distance is positive, but displacement is negative. Distance is positive, displacement is negative. From this we can write displacement can be negative, but distance always positive, okay. And one more important difference I will write. Displacement is a vector quantity because it has direction, whereas distance is a scalar quantity, okay. And I'm going to tell you important units of both distance and displacement. In CGS system, distance to displacement both units are centimeters. In SI system, meters, okay. And practical unit is kilometer, because when you start the car you travel kilometers. When we talk about train, it travels kilometers in reality, not meters, it travels kilometers. So this is a practical unit. CGS unit is a centimeter, SI unit is a meter, practical unit is a kilometer. Of these both distance and displacement, right? So after writing the differences, you write the units of the distance and displacement. Both have same units, right? I hope you understand the major differences between the distance and displacement with the help of this example. Please note down.